Imagine for a moment that you are a secret agent, perhaps on the trail of a rogue sentient toaster, accused of bombarding the public with carcinogenic carbohydrates, and you need to track it subtly. So to segue seamlessly into our project, we first need to improve our car performance before setting up the tracking or chasing functions. So let's build a new test arena. A little bit of sand, a few trees, and then I need to draw the boundary so that we can set up the car navigation systems. And then we'll just add the car and see how it runs. And as before, you can see it gets caught in a little bit of a cycle where it's just doing a figure of 8, where it circles one clump of trees and then comes back. Now before we go and improve this driving capability, I just want to add a trail to the car. Now the trail was super easy to add, and I basically used this data structure called a deck, and I have a video on it which is linked in the description, but it's basically a very efficient list where you can do things at both the front and the back of the list. If we're driving, we update this list by appending to the front of it the car position, and then what we do is if we have less than 60, we iterate over the car positions and we just colour them like this, and that gets them to fade slowly into the background, the radius getting larger as we go up the index, so that it sort of dissipates out as it fades. If we have more than 60, we just add a trail.pop so that we're keeping it down at being 60 long, always removing the value that was furthest away. So let's see how this looks. And there we can see a nice trail behind the car. Looks a bit like sort of smoke or dust being thrown up. I also added this when I clicked that you could see the rays coming out and the boundary. It's just a nice little thing to debug and test the program. Okay, let's improve how this car behaves by updating its guidance system. So in order to improve the guidance in the car, we had to make it become more decisive, because the problem was that at every frame it was reconsidering its direction. So what I did is create this self-decision counter within the car, and if we reached a certain level, then it would be enabled to carry out another decision. And you can see here that we have a few functions in our update guidance where there's just this simple self-find min-max rays. It returns the minimum distance ray and the maximum distance ray. We use the minimum distance ray to see if we're too close to an object, and if we're too close to an object, then we override any guidance with an evasive action. Otherwise, we just do a decision counter check. So basically, when we're not going to collide with something, we drive wherever we like at a steady pace. Now, this is the code for those different functions, and you can pause and have a look through this. However, I just want to highlight this point here, that when we are just doing our normal run-of-the-mill things, we're not going to collide with anything. The car can really just wander the entire arena unless it's going to collide. So let's see what this looks like. And here we go. You can see that the car is much more responsive to the environment, and it's also exploring a lot more of the space. You can see like this difference of response where one time it will go around the back of the trees and then it will go in the front of the trees. So there's clearly quite a lot of dynamism to how the car's behaving, and it's exploring the arena much more than when it was just sort of looping and trapped in that minima. So this is a great improvement. And it has some sort of interesting action where you just wouldn't expect it to behave like that, where it almost does a 180 here and then heads back up to the other corner. So this is a definite improvement, and now we can look at how we can track an object. So in order to track a car, we're going to make use of a target argument that we pass in the update function, and this can get passed through a bunch of other functions where it ends up at the decision counter check. And basically, if we have a target, then we want to preferentially turn towards that target. So that's where we enter this turn towards target function, which is down here. We're going to need to get an angle which is relative to the direction of our car, and we can use that to shift our car either left or right as we turn. Now, it can be useful to visualize these left and right positions, so let's just see what they look like when we're tracking the mouse position. So you can see here that blue is for the left hand position and red is for the right hand position, and so clearly the car needs to be turning towards the right to get to this position, but now it needs to start turning left because it's basically altered its position. It's a very subtle form of tracking, and now you can see that it's angling in. There we go, it went through the point, and it will continue to do this, but it's not a direct, like, angling straight onto a target. It slowly moves as it's allowed to make decisions towards the target. And of course, when it deflects off a wall or evades like a barrier, it will sometimes find itself in a better position to angle towards the target, like this time. There we go. So it's quite a nice way of sort of subtly putting something that maybe a player wouldn't notice straight away, where a car is actually slowly tracking onto them, but isn't straight away heading directly towards them. Anyway, let's implement a second car. Now, implementing a second car is really easy. We obviously have to initialize the car object, just like we did with car 1, and I'll have a separate image for car 2 as well. But what we can do is, as you can see here, we just pass car 1's position as a second argument to the update function. Bear in mind that if we don't pass any position at this point, it just defaults to none. So car 1 is just driving around completely unaware of any targets to track, but car 2 will be aware of car 1's position and be attempting to track it. Let's see how this looks. And here you can see how the car tracking is working, where the grey car is tracking on the red car. And you can see that sometimes it's a little bit convoluted and it doesn't always look like it is tracking that car, but it's slowly making adjustments to effectively narrow in onto the red car. And here you can see that I haven't incorporated a collider into this program, so the cars just pass straight through each other. However, it'd be nice to implement a barrier for the car. So what I've done is effectively just added the rectangle dimensions to our barriers for each car separately, so that car 1 will see car 2 in the barriers and car 2 will see car 1 in the barriers. And that will just enable them to effectively avoid each other with the same evasion mechanic that we built in to the guidance function. And there we have that, and you can see them sort of dancing around each other a bit. They're getting very close, though it does seem like the grey car is trying to push the red car out of the arena. Let's build a racetrack and see how they perform. Load in our cars and off they go. Now all that remains is to chase our rogue sentient toaster. Thanks so much for watching, and I'll see you in the next one. Bye!